Hey everybody, welcome to video 11 in the UE5 vehicle tutorial series. This is part 2 on the vehicle AI. In this video we will be allowing the AI to know how fast it should be going at all time, to be going as fast as possible while slowing down for these curves so it doesn't drive off the track. And the way we're going to do this is to use the little bit of code we used last time to determine the angle of the steering. We'll use that to look ahead even further on the track to determine the angle the track is going to be at and use that to modulate the speed by changing the throttle and brake value. And that's a pretty big chunk to cover again, so let's get started right away. Let's open up the AI blueprint. Oh, and actually the first thing we're going to do is to fix a bug. You know how previous video I told you I've actually moved the first point of the spline right here, so this is my starting line now. In the last video you can see here the AI cannot look past the starting point, and I told you it wasn't a big deal and there was probably a fix for that, and I was wrong. It is a big deal and there is a fix for that, which I'll show you right away, and I'll show you why that's a problem. If we just increase the distance at which we look ahead to a big amount, let's say 2500, and it's also a big deal for the AI avoidance system that we're going to build later on. But just now, see how it can't look as far as it wants to, and that kind of messes up the angle of approach here and makes it do a weird loop to try and get back onto the track after it went too far because it couldn't look ahead. This is a problem. We can't have that. This is unacceptable because I'm a perfectionist. So let's go ahead and fix that right away. Let's disconnect that for now. Let's actually delete it. We'll replace it with something better. I found out you could do much better than that. And because this is gonna get pretty big, let's select all of this and make a macro out of it. Now the reason I'm making a macro instead of a function is a function you have to put it onto the execution line here, and a macro is like a variable you can just place anywhere on the graph and just have that little bit of calculation just neatly tucked away in a node you can put anywhere. Let's go ahead and name that look ahead on spline. Oops. Look ahead. And because we probably want to be looking ahead to determine the speed, we'll have to be doing this before we set the throttle input. Let's move things around a bit. Like so. Yeah, should be good enough, I guess. Sorta, kinda. Plug that back in here. Okay, whatever. Sorry about that. You're just gonna have to deal with that a lot. So let's open that back up, and I'll explain basically why that problem is happening. Let's make you a little drawing here with nodes. I know this is looking funny, but bear with me here for a second. Let's put that back the way it was. Okay. Let's say, oh, I can't do that. Oh, that's too bad. I should have tried that before. Oh, whatever. I can't make a loop out of it. Okay, that's gonna work too, I guess. So the problem we're having here is that this would be our starting point, and this would be our ending point, but they're all the same location, right? So when we're here, for example, and we want to look ahead past the looping point, we're not looping back past the first one. We're kind of hitting a wall here, right? Because I guess that this node here doesn't account for looping splines for some reason. And that is why we're getting a bug where we can't look past our starting point. Because the spline here can't go past the maximum length of the spline, and it's not going to loop around by itself. We're going to have to make it loop around with a little bit of mathematics, but only when we need to. So let's first determine whether we need to do anything or not. Right here, we are going to use a select node, select float. The condition here, we're getting the length of the spline. So sorry, this is our spline component. Let's get our get spline length here. Now don't confuse this with spline duration. Spline duration is a value you can set to anything at all. It is going to be used mostly for animations. Spline length, on the other hand, is the actual length in centimeter that your spline is stretching across, which is also what this here is returning, is how far ahead onto the spline in centimeter this key is. Alright, so what we need to do here is get the end of the spline, which is the maximum length it can be, and remove from that the distance we want to be looking ahead. Okay, now this graph is going to get pretty messy, so I'll try to keep it organized so it's readable for you. And so if the distance we want to look at is greater than the length of the spline, so let's plug that into a greater, plug that here into our condition, and actually we want to know here if our distance is greater than this result here. This result here basically represents how far on the track we can be without our prediction distance being greater than the length of the spline. And so if that returns true, we're gonna have to run some extra calculations. If it is false though, we can just proceed as normal and use this little thing here. Let's actually use some simple numbers here so I can demonstrate how that works. Let's say this is 0. This is your starting point. This is your end point, which is going to be, let's say, 100 for the length of the spline, but it's also going to be 0 because it's looping around, so it's also your starting point, right? Player here is, let's say, 75 units along the spline, and player wants to be looking 30 units ahead of its position, like so. Now player is only 25 units in front of the finish line, and so if you want to be looking 30 ahead, that would put you 5 units past the last or the first point. And so the result of that would be 5 units past 0. Now right now what we're getting is 75 plus 30 is going to be clamped at the length of the spline, which is 100. And so we're now looking only 25 units ahead when we want to be looking 30. And that's the bug we're seeing, and the way we're going to fix that. This is a spaghetti mess. Let me see if I can make some room here. This is going to be hard to follow if I don't mess around with it a little bit. Let's go ahead and also get that transform wire out of the way here. That's a little better. Guess that'll just have to do. Although that spline length here I don't really need anywhere else. Oh, never mind, I do actually. Okay, let's make some room here. And so what we want to do, if we are too far ahead on the spline to be looking ahead without looping around, what we want to do is we want to get the position along the spline. Well, actually it's the other way around. We want to get the length of the spline minus how far on it we are, like so. And then we want to get how far ahead we want to look, and we want to remove that from the result of that. And that is going to be the position on the spline at which we're looking. And again, let's use our simple numbers here to tell you how that works. So what we're doing here is getting the total length of the spline, which is 100. We're removing the player position on it, which is 75. And so we get a result of 25 here. Okay. And then we're going to take how far ahead we want to look, which in this case here is 30. And we're going to remove our result, which is 25, from that. That gives us 5. And so we want to be looking 5 past 0. Okay? Super simple. Nothing to it. Just kidding. And so this is what this little code here does. Now let's, again, let's test that, make sure I didn't mess that up and it's actually working. Oh, sorry about that. I disconnected the sphere trace, so we're not seeing anything. Let's put that back in. Since we made a macro out of this, we're gonna have to go to the outputs here, add a new one. Let's call it location. And let's rename the other one distance, just so we know what everything is doing. Location here should be a vector, because it's going to be coordinates. And it'll be set right here. Get location at distance along spline. So that's going to return the location at which we are going to look. We'll go back in here into the event graph, get that location. And the better method I was telling you about, you can do a debug, or sorry about that, draw debug. You get many options here: arrows, boxes, capsules. So you can use anything you want for any different values you're going to want to be displaying on the map for debug purposes. I will be using a circle. Plug the location here at the center. Set a radius for it. Number of segment. You can put anything you want here. So you can use circles with different amount of segments to be displaying different things. You can go as low as 4. So that could be a square, pentagon, octagon, whatever you want. It can't be a triangle for some reason. Set the color to something I can see despite being colorblind. Duration should be 0 because we're going to draw one of these for each frame. Set the thickness to something like 5 so we can see it. Axis here, if I remember right, should be set to 1 and 1. So 1 on the X for the Y-axis and 1 on the Y for the Z-axis. This is so confusing. You have to do this in order for the circle to be facing up, although it doesn't. And now, as you can see, this is working. The AI is seeing past the looping point and behaving properly, steering along the track, which is important for many things to come, such as avoidance. And with that little bug finally fixed, let's go back here into the controller and use steering angle to set the speed. Let's go ahead and make some room. Something like that. Let's unplug that. We're going to move that around, or actually copy and paste it. We're not gonna need that deep, but you know what? Let's keep it around. We might use it later. And then, okay. Let's go ahead and reopen that macro. Let us delete that junk. Set a new input for it. Which is going to be a float. And that will be steer prediction distance, like our little variable here. Okay. And we are going to replace this variable here with that input, because we're gonna use that little macro for the throttle as well, but not with the same distance. And so just like so, can actually move the input here for no reason. And let's give that a more generic name, like prediction distance. There you go. Now also, this here, this is not the distance, this is the steering input from 0 to 1. Let's call it that. And then actually no, let's not. We'll do that outside that little macro, because this is steering related only. What we're going to be outputting here is the yaw instead. Just the yaw and location is all we're going to need from that macro. And this is not the distance, this is going to be the angle. Yeah, okay, angle. That's going to work. Let's cut that. Go back to the event graph here and paste it. This angle here, back into the value, and into the steering. Okay, because we're gonna have to do a little bit of messing around with that map eventually, and so let's not have that inside of the macro. Again, let's move stuff around a little bit. Hopefully keep this readable. If I can stop messing that up. Okay. Okay, cool. That's actually backward. Alright, better. Let's get that again here for the speed. Now that here, that we are going to keep as is. What we're going to do is we're going to set that target speed to something different, which is not going to affect the input that we put in the throttle. Now here, this is the steer prediction. And we've set the steer prediction here to 2500 for demonstration purposes. Let's put that back to 1000. We don't need to be looking ahead that much for the steering. We will be looking ahead a lot more for the curve detection. So let's add a new float. Let's call that throttle prediction distance, just to be consistent. Let us set that, I believe. Yeah, I'm getting an error. Not there yet. Wait a second. Wait for your turn. And the speed prediction, or the throttle prediction distance, let's go ahead and set that to something like, how about 3000. We'll see how that works. You go back in there, and I'm gonna need that new variable I just created and our little macro here. Look ahead on spline. Why am I having two of them? This is weird. Okay, I have two of them for some reason. Just ignore that. Check ahead is not the one we just made. Alright. That's good. Actually, this is my second time recording this tutorial because I kept messing up. Guess I forgot to delete that function before starting again. Okay, and now again we're gonna grab the angle out of that. We're gonna use that angle, actually the absolute value of that angle, which we're gonna split back into positive and negative later on. I'll need a lot more room than that. And that here is going to be fed into another map range, like so. Let's again start with some generic values that I've tried and I know works great. Let's go with 10 and 30. So anything from 0 to 10 degree from the forward vector is going to output actually our max speed. Yeah, actually this is going to be the max speed of the car here. Let's create a float for that. Max speed, and while we're at it, let's go ahead and create a min speed as well, because we're going to need that too. And so from 0 to 10 degrees, we're basically not going to affect the speed at all. We're going to output our max speed as our desired speed. And now, if we're 30 degrees or more, let's go ahead and set that to 25 as I did in the other blueprint. In theory, that should be your minimum speed. Don't know why I've set it to a hard-coded value. Now let's go back to our variables here, compile that so we can set default values. Maximum speed, I'm setting to 105 miles per hour. That is going to be entirely dependent on what kind of car you're driving onto what kind of track. Minimum speed, again, I'll go with 25. Pretty sure that was meant to be plugged in here. That looks good. That looks good, and that is our desired speed, just like that. Sorry, let's grab our target speed here, set it to this. And just like that, we have established what our desired speed should be according to the angle we're getting from looking ahead onto the spline, right? And with the target speed, we did like we did last video, just get our actual speed, target speed, difference between them, and use that to set the throttle. Now we're going to need to do that for the brakes as well, because we just might be going too fast if we're going downhill, for example. And so for the brake input, let's go ahead and make set brake input right here. That's going to need another map range. Let's copy and paste that one, because that's easier than typing. Value is going to be the exact same value, which is target speed. No, actually, exact same value being target minus actual speed, which is the difference from our speed and the speed we want. That should be 2 and 10 is what I set. The output of that should be 0 to 1 as well. Oh, and for some reason, that here actually needs to be backward. Nope, sorry, never mind. That one needs to be backward. Minus 2, meaning we're going 2 miles an hour too fast. 2 minus 10. So if we're going 10 or more miles per hour over the speed we want, we will apply full brakes. If we are going 0, which is the speed we want, up to 2 miles per hour, we're applying no brakes. and then in between just gradually adding more and more brake. And now if we do a print string for the actual speed, we'll be able to see what the AI is doing with the throttle. Let's go ahead and make another print string. Set the duration to whatever. Set a key of speed so it overwrites itself instead of making a huge list of print string. Again, set that to a color I can see. Go ahead and grab our forward speed in miles per hour. Round it so we don't get a whole load of decimals, and feed that into our print string. Just like that, we can actually go ahead and try that out. You can see it's going pretty fast. It's going 100 miles per hour in the straight sections, slowing down almost to minimum speed for those sharp turns, and then speeding up again for the straight lines. As you can see, it is not perfectly matching the spline here, which is fine, because those are pretty sharp corners for going 100 miles per hour, and we're not looking that far ahead, so we can tweak that to get it to stick to the track better than that. Let's go ahead and do that. Let's actually reconnect here our little draw debug circle so we can see the steering distance, which is going to be this location here. Let's go ahead and copy and paste it so we can do the same for that one here, which is setting the target speed just like so. Again, fetch the location on that one. Then we'll be able to see kind of where it's looking at, and we'll use that to kind of tweak the distance. Also, we should make that distance get longer with the faster we're going, because the faster you go, the less you want to steer. You don't want any sudden steering at 100 miles per hour. You want to steer smoothly, and so you want to look further away ahead of you. Also, your reaction time is a lot longer when you're going that fast, especially if you have to brake for the curve. You want to be doing that with a lot of heads up to avoid sudden braking and skidding, you know, overall losing control. You obviously don't want that to be too long. You don't want to drive like a grandpa during a race, so you want to get that value just right to get the most out of your tires, I guess. So again, radius, let's put it a different color. Not red. Let's go with blue. I like to actually be able to see my debug things. Okay, yeah, let's have a look at that. See what that looks like. Yeah, I'm not seeing blue. Screw that. Let's make it white. Pretty sure I can see white. That's gray. Oh yeah, I can see that. And that is not nearly far enough as I suspected, especially for those sharp turns here. Hence why it's not slowing down enough for this turn. So let's throttle prediction distance. Let's set that to, let's say, 4,500. We'll just play around with it a little bit, and the minimum speed as well, which here we've set to 25. I believe I can set that higher than that if I get the look at distance dialed in properly. Yeah, that's better. You can see it's looking ahead a lot more, cutting in that corner a little bit more, slowing down to the minimum speed. That's a bit of a steep corner, although not that much. I reckon it doesn't have to slow down that much. 25 miles per hour for that is a bit excessive. So there's two things you can do when you find out it slows down too much. One of them would be to, if I can find my way around my own blueprint, that would be to increase the maximum angle. Now, if I go ahead and set that to 45 instead of 30, when you get into a 30-degree curve, it'll slow down a lot less without actually changing the minimum speed. So when you get a 45-degree curve, your minimum speed is lower. Or you can just go ahead and do both. And that's why I say you might have a lot of playing around with those variables to do to get your cars to follow the spline properly. And those variables might have to be like vehicle dependent at some point. Well, you can see here we're not reaching minimum speed at all. We're actually going, I think that was 45 miles an hour in that curve, and it did it just fine. See, 56 is as low as we got, and it handled that corner perfectly, so we can keep playing with those variables. So it's now hovering anywhere between 100 and 67 miles per hour, which looks pretty good for an oval of that size. I think that's reasonable. But again, if I just pop into the map and race against it, I'll have a better idea of how good it's doing. But that's going to be that for tonight, because it is actually night here, pretty late at that. And we'll see in the next video how far we can get without this being an hour-long video. I reckon this one is long enough already. So I hope that was helpful. And again, if you enjoy my content, consider subscribing to my Patreon. You can also join the Discord server to ask any questions. We're a few people on there already. I think we're nearing 40, and most of them in there are pretty useful. If I'm not there, they will gladly answer your questions if they can. So, nice little community we're building on there. Feel free to join, and I will see you next time.